how do we assign IP addresses? So IP addresses are assigned as blocks. Okay, a block of IP address is assigned to somebody. From them, the individual users can get one or two IP addresses. So generally, it is assigned to any organization or institution, and individuals can get it from them. And to identify the block, then any IP address belongs to that we have to identify means we are using netmask or mask. Okay. So what is this netmask? This mask is again a 32-bit address similar to IP address, but in which all net ID portions are filled with 1, all host ID portions are filled with 0. So now, number of blocks and block size in the classful IPv4 address. So as we have told in class A, 2 power 7 and 128 number of blocks or 128 number of networks. And each block is having these many addresses. So that is the size of the block. This is for host, reserved for host, so unicast application. Unicast means one-to-one, host to destination, one host to another host. And in class B, number of blocks will be 2 power 14. So that is 16,384. And each block is having this size. Okay, 2 power 16, 65,532. This is also for limited. And for class C, these many number of blocks or networks are available, and each network is having 256 addresses. And this is also for limited. And class D, only one block is there, and that block is having these many addresses. All these are reserved for multicast. And in class E, only one block is there. It is having these many addresses, and that is reserved, not used for anything. So default mask for classful IP addressing will be for class A, first 8 bits. So /8. Okay. So if I have to represent in dotted decimal notation, it will be 255. First 8 bits all 1. So 255.0.0.0. And for class B, 255.255.0.0. And for class C, 255.255.255.0. So we should say /8/16/24. So now we shall revise. How many classes are there in classful addressing? What are they? 5 classes are there: A, B, C, D, and E. What is the default mask for class A addresses? Default mask for class A is 8/8. What is the default mask for class B addresses? /16. First 16 bits are net ID. What is the default mask for class C addresses? First 24 bits. So /24. Which class is reserved for multicasting? Class D. What is the purpose of class E? Reserved for future use, and at present it is unused. How many addresses are there in class E? Class E starts with 4 ones. So remaining 28 bits we can change. So 2 power 28 addresses are there. So only one block, 2 power 28 addresses are there. Identify the class of this IP address. So we have to check with the first octet. So this is, I think it is coming under the range of class B. Yes, it is class B. How many number of blocks available in class A. Blocks here also represent number of networks. So how many number of blocks or how many number of networks available in class A? So class A starts with 0. Remaining anything we can choose. So in the first 8 bits, only 1 bit is reserved. Remaining 7 bits we can change and different combinations. So those many blocks we can have. 2 power 7 blocks are available. That is 128 blocks. Now, how many number of blocks available in class B? Class B starts with the value 10. So in the total 8 bits, first 2 bits are fixed, remaining 6. Okay, so we can change, and for class B, one more 8 bits are also there for net ID. So totally 8 plus 6. So here only 6 is available and here it is 8. So totally 14. So 2 power 14 blocks we can have. And for class C, so in the class C addresses starts with the value 110. So first 8 bits, next 8 bits, another 8 bits. 24 bits are reserved for net ID push. So those many blocks we can have. But here first 3 bits are reserved. So here I can have only 5. So 5 plus 8 plus 8. 8 plus 8, 16. 16 plus 5, 21. So we can have 2 power 21 blocks. Now, in IPv4 addressing, how do we define a block of IP address? So it is defined as IP address with a slash notation. Okay. So this is defining the IP address, any IP address in the block. And the slash n defines the mask for that particular. So each address in the block can be considered as a 2-level hierarchical structure, as I told. Leftmost n bit prefix defines the network or net ID. Rightmost 32 minus n bits define the host ID part, suffix. Okay. Now, given IP address 132.16.17.85, default class B mask. Find the beginning address. So the beginning address is always known as network address. Okay. First address is always given to the network. From the second address only it is given to the host. So we have to identify this. So how do we identify? Default class B mask, we should remember, that is first 16 bit /16. So based on that, default mask is 255.255.0.0. Okay, /16. So first 16 bits all ones, remaining bits all zeros. Okay, so in that way, if this is applied, and we have to apply AND operation between the given address and this. The first 2 octets are preserved because whatever bit I have here is ANDed with 1 means the same bit will come. And here all these are 0. So if I AND this part here, this value becomes 0. So 132.6.0.0. That will be the beginning address, also known as network address for this block. Okay, or for this IP address. Now, given IP address. So this is the given IP address. They have given the mask value also /16. Now, identify the 32-bit net mask. So how do we identify that? Based on this value. /16 means first 16 bit all ones, remaining all zeros. So we could identify that 255.255.0.0 is the 32-bit net mask. Okay. Now, a block of addresses is granted to a small business that needs 15 addresses. One of the addresses in the block is 205.15.37.39/24. Now, this is a class C address. By simply seeing this, we could guess. So, it is a class C address. So, the question here is, what is the size of the block? That is, how many number of addresses are there? And second is, first address in the block is what? And last address in the block is what? So, this we have to identify. So, we have to remember the constraints first while allocating the block. Those are, the addresses should be contiguous. Okay, all the 15 addresses we are assigning, for example, should be contiguous. Okay, continuous. Then the number of addresses, total number of addresses in the block is a power of 2. So I cannot assign 15. It is not the power of 2. I can assign in the power of 2. Okay. So if it is class C means I can assign it from only a class C. So each class C address is having 256 addresses. Each block in class C is having 256 addresses. So that only I can allocate. And first address should be divisible by n. So n value, if I take 256, means first address should be divisible by 256. So we shall see how it is. First address. So if I take a sample address like this, and I should convert each of this into binary, then the total value, the total decimal value I should take. So this is 128, and after 128, this will be 250. Okay, 256 plus 128. So that value I should take. 256 plus 128. So that becomes 384. So 384 should be divisible by the number of addresses. Yes, 16. So 224. So the number of addresses in the closest power would be here. So we could see 15 addresses they want. The closest power of 2 is 16. So it should be divisible by that number. Okay. So we can say 384/16 is divisible by n. So we can allocate a block like that. Okay. Now, a block of address is granted. So the question is coming back. Okay. So now one by one we shall identify size of the block, first address, last address. Okay. Now, to find the number of address, that is size of the block. So we should use the formula 2 power 32 minus n. N is the masked bit. Okay, so this is the slash notation, masked bit. N is the masked bit. So for the given question, 24 is n. So how do I calculate? 2 power 32 minus 24. So 2 power 8. So 256 addresses. Okay, a block that contains 256 addresses, that is reserved. And to find the first address. So to find the first address in the block, we have to set the rightmost 32 minus n bits to 0. So that will be the first address in the block. So first, the given address is to be converted into binary. Then I have to take the mask value. In that, last rightmost 32 minus n bits. What are they? 32 minus 24. So 32 minus 24 is 8. So here. Okay. And 8 rightmost bits I am changing into 0. So I am getting 205.16.37.0. So this part completely becomes 0. That is the first address of the block. Now to find the last address, rightmost 32 minus n bits to be set to 1. So given address, convert it into binary. The last 8 bits, I should make it as 1. That is the final value. Highest value I can represent. So when I do like this value becomes 255. We have another way also to find the same. So first address in the block is always network address. This is to represent the network or subnet. Last address in the block is a broadcast address. So it is for sending messages to all ports. In between addresses are only reserved for the port. So in another way, how do we find it? Number of addresses in the block. So if the subnet mask is known, then not of subnet mask, negate. All the bits are to be negated. Then the decimal value is added with 1. For example, if the subnet mask, not of subnet mask, decimal value is becoming 15 means plus 1, 16. So that will be the number of address. First address in the block, given address and subnet mask. So in binary representation, if I do this, then I will get the first address. Previously, what we did, 32 minus n, last 32 minus n bits we made as 0 to find first address. The same thing we are achieving through the subnet. Okay, to find the last address, earlier we did 32 minus n, rightmost bits to all ones. The same thing we are achieving here through in a different way, given address or not of subnet. Okay, we shall see the example. For the same address, if I have to apply not of subnet mask plus 1, then subnet mask is /24. So all first 24 bits, all 1, remaining 0. Not means all these are converted like this. Okay, so if I take the decimal value of this, then that becomes 255, then plus 1, 256. So 256 address. We got the same result. Now, first address in the block. To identify the first address in the block, given address and subnet mask. So this is the given address and the subnet mask. Okay, so if we perform and all these values become 0, we will get the value. So 205.16.37.3. Last address in the block. So we could see given address or not of subnet mask. So given address is given, subnet mask not value is given, we should perform OR operation. So the result will be like this. So what value we have given here? So irrespective of this, everything becomes 1 here. So the result will be 205.16.37 or 255. So that becomes the last one. So now, what is the drawback in classful address? The address depletion. Depletion means quickly it will go off. We don't have any more addresses to assign, but still somebody is requiring that. So in this example, what we have seen now, to allocate 15 addresses to a small business, we are choosing class C block, which is the smallest one, that is having 256 addresses. So only 15 addresses they are going to use, remaining 241 addresses are wasted. So that is the main drawback in classful addressing. So nowadays we are following classless addressing model. Okay, but classless addressing is following the concept of classful addressing. Okay, so it is actually derived from classful addressing. Okay, so now address depletion means scarcity of IP addresses. If we have, could you guess how many organizations in the world today? So many, right? So we have In each of these classes, these many blocks. If I add all these blocks, it may come around again 2 million. Okay, that's all. But do you think only 2 million organizations are there worldwide? No, it will be really higher than that. So how do we assign? So if we assign in this way, fixed size blocks, then we cannot allocate to all the organizations. So we are not going for fixed blocks, fixed classless addressing. Okay, so that part we shall see in another video. The classful addressing is obsolete, but based on this, the classless is derived. Okay, but the advantage here is fixed prefix length makes us easy to identify the network. Okay, it was very easy with simply seeing the IP address. We could say this is belonging to which block, which class. Everything we can identify. Okay. So to manage the address depletion temporarily, subnetting and supernetting are used. Okay. Subnetting means dividing large block into smaller ones. Supernetting means combining several class C blocks into larger blocks. That is one example. Class B block can also be combined. So to revise, what is subnetting? Dividing the larger block into smaller ones. What is supernetting? Multiple networks combined to form a bigger network. Okay. Now, this is the address 80.6.17.85 and the default class A mask. What is the beginning address? So how do we identify that? Default class A mask is /8. Okay. So /8. So this is the mask. Only first byte should be preserved, and all these are ANDed with 0 means those all become 0. So the beginning address, first address will be 80.0.0.0. Now, another question. Given IP address is 210.6.17.85/24. Identify the 32-bit net mask. So take this value 24. First 24 bits all 1, remaining 0. So how do we make that? 255.255.255.0. That is the 32-bit net mask. Okay. Another question. A block of addresses granted to a small business that needs 500 addresses. So class C is not enough. That is having only 256. One of the addresses in the block is this /16. So you could guess this is a class B address. Okay. Now the question here is, what is the size of the block? What is the first address in the block? What is the last address in the block? So this you can apply based on the formulas we have seen previously. Okay. So you can try it yourself. You can check the answers. Okay. Thank you.